Hi everyone, it's Ms. Schieber. In this video I'm going to be teaching you kind of a trick for how to make structural formulas out of molecular formulas. It's just some patterns that tend to happen that are going to make it easier for you to figure out some structural formulas. And the trick is called the Honc 1, 2, 3, 4 rule. Yeah, it has a fun name there. So let's start with this. Here are some structural formulas of 3 different covalently bonded molecules. Take a look at the different atoms and try to count how many lines are connected to each type of atom. And that also means how many bonds are attached to that atom. Okay, so take a second, pause the video, and try to count for carbon, oxygen, nitrogen, and hydrogen. How many bonds does each of them have? All right, so for carbon, you should have counted that they all have 4 lines attached to them, or 4 bonds. So like, you can look at any carbon, but here's one, and it's got 1, 2, 3, 4 lines, or 4 bonds. Another carbon, 1, 2, 3, 4, so carbon tends to bond 4 times. Oxygen, if we find an oxygen, here's one, tends to bond 2 times. If we look at this oxygen, it's only connected to one thing, which is carbon, but it's connected twice. It's got 2 bonds to that carbon, so it's still making 2 bonds. If we look at nitrogen, there's a nitrogen right here, and it has 1, 2, 3 bonds. And finally, all of the hydrogens, you should notice, only are connected by 1 line. They only make 1 bond. So we can refer to this pattern as the Honc 1, 2, 3, 4 rule. Let's just fix that. There we go. Where hydrogen makes 1 bond, oxygen makes 2 bonds, nitrogen makes 3 bonds, carbon makes 4 bonds. Honc 1, 2, 3, 4. So hydrogen, oxygen, nitrogen, and carbon are the most common nonmetals that you're going to find in covalently bonded molecules. There's a few other nonmetals in there like fluorine or sulfur, and we'll learn about what kind of bonds those form later, but for now we can make a lot of different molecules just using these 4. Okay. Quick note that things can form multiple bonds between the 2 same atoms. So in this picture, right, we've got just 1 line, and we would refer to that as a single bond. In this picture, this bond is a double bond. So these 2 carbons are bonding to each other twice, and then you can even have a triple bond where they're bonding to each other 3 times. And notice in all of these molecules, the carbon is still making 4 total bonds. It's just bonding more times with one thing in the triple bond or the double bond. So you've got a molecular formula like this. So the first thing we want to do is draw the carbons in and connect those. So this has 2 carbons. I'll draw those in and bond them together like that. Next thing we do is add any oxygen or nitrogen atoms. This one has 1 oxygen atom, so we can just connect that on to the carbons. And last is filling in the hydrogens. This has 6 hydrogens. What we can do is see how many more bonds each of these things needs and just put hydrogen in for those bonds. So carbon needs 4 bonds. This first carbon on the left has 1 bond, so I'm going to put in 3 hydrogens on that one. This next carbon already has 2 bonds. It needs 2 more, so 2 hydrogens there. And then this oxygen needs 1 more bond, so I'll put a hydrogen there. If I count these up, they're 1, 2, 3, 4, 5. 6. Now if you did this and it turns out you didn't end up with the right number of hydrogens, you had too many hydrogens, then maybe you needed a double bond somewhere. But for a simple one like this, it works out just to add the hydrogens and make sure you have the correct number of bonds. Now sometimes there are different correct ways to draw a structural formula. C2H6O could be drawn like this. This is the same thing we had on the previous slide. But there might be other ways to arrange it. For example, I could have done like this and put the O in the middle, and then my 6 hydrogens like this. So I have the correct number of everything here. Carbons all have 4 bonds, hydrogens have 1, oxygen has 2 bonds. So this is also a perfectly acceptable structure for that molecular formula. These two molecules are different, and we would call those isomers of each other. Same molecular formula, but different structure. So for some of these kinds of questions, there can be more than one right answer. Now I'd like you to practice. Try drawing a structural formula for C4H11N. Go ahead and pause the video. All right, you should have drawn your structural formula now, so I will show you one way that you could have done it. Probably the simplest option would just be to put the 4 carbons all in a row, although you could have maybe done something like that as well. That would be fine too. Next we need to add on the nitrogen. So in this one, let's just keep them all in a row, and let's try another option, put the nitrogen down there. Okay, and now we need 11 hydrogens. So I'm just going to start filling in hydrogens to make sure everything has the correct number of bonds, and then see how that looks. So this carbon needs 3 more bonds. This carbon needs 2 more. That one needs 2 more. That one needs 2 more. And then nitrogen, remember, needs 3 bonds. So it's already got 1, so it needs 2 more. And let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. 11 hydrogens. It worked out. So this is probably the simplest structural formula you could draw. If you had done it like this, let's see, we'll put 3 hydrogens there, so that has 4 bonds. Getting a little crowded, but that one needs 3 more, that one needs 3 more, and then nitrogen needs 2 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Still 11. So this perhaps could be another option for your structural formula. All right, so that's going to end this video. You can go ahead and move on to the practice now.